Hi everyone, welcome back to Real Estate Redefined, a web series brought to you by Cisco's Hybrid Work Center of Excellence team. My name's Murray, and I'm joined by my colleagues Ansar and Ryan in delivering this web series to you today. So far, in this web series, we've covered the concepts of delivering an intelligent-enabled space, the ideas of converged network architecture, the concepts around energy networking, and then in last episode, we covered switching infrastructure from the Cisco portfolio. In today's episode, we are going to cover wireless infrastructure. For those returning visitors, thank you so much for continuing to watch and learn from our web series. We hope these episodes are helping you and your colleagues understand what is possible with technology and what the future may hold for the built space. For those who are just joining us for the first time today, please make sure to check out our YouTube to watch the previous episodes in the series. Now let's jump into episode 5. In our episode today on wireless infrastructure, we will be breaking it down into 4 main topics as well as a demo. The first topic is the era of hybrid work and the challenges companies face when deploying wireless in an office space. We will then talk about Cisco's Catalyst wireless solution. Our third topic will be how wireless can empower workplace transformation. We'll then show a demo of how to use a Cisco access point as a BLE gateway. And finally finish off with how sustainability is built into the design of Cisco wireless products. I'll now hand it off to Ansar to start us off on the concepts of episode 5.
Thank you, Murray. Today's dynamic environment requires seamless connections for more people, devices, and things than ever before. Networks, whether in the core campus or on the edge, must facilitate new ways of working, allowing employees to utilize any device from any locations. As companies embrace automation and new hybrid work setups, they are on the lookout for simpler, more flexible operation methods. Meanwhile, the workplaces are changing too. Many organizations, including Cisco, are transforming office spaces to prioritize the user experience, comfort, sustainability, and overall employee satisfactions. With the rise of bring your own device, almost everyone brings their gadgets to work, and even the laptops provided by the companies may not always have Ethernet ports. In many areas inside the office, mobility is absolutely critical than ever before. Wireless connectivity is the primary medium, and transitioning into a Wi-Fi first approach, or even there are areas inside the office particularly preferring wireless only setups. In this era of hybrid work, high quality video calls are a must, and the usage has significantly increased. Collaboration apps demand faster, low latency connections for smooth video and reliable performance. On the other hand, the building operators are hungry for data-driven insight to optimize the spaces as well as minimize the cost, all while ensuring high quality, comfort, as well as sustainability. Meeting these demands means integrating more and more IoT devices into infrastructure to collect the data, which platforms like Cisco Spaces can analyze the data. But all this puts more strain on the network infrastructure, both on wired and wireless, which can become a big challenge if not handled properly. The network is the backbone of the modern office, enabling that IoT integrations and providing that seamless connectivity, high bandwidth, low latency, as well as the necessary security for all the endpoints inside the building. But many offices still rely on traditional Wi-Fi, leading to slowdowns, delays, and frustrations among the users, impacting the overall productivity. Furthermore, traditional wireless systems lack IoT readiness, meaning they are not all well equipped to meet the evolving demands of this modern workspace that is seeking digitization for data-driven insights as well as sustainability. So my questions to you: can your current wireless infrastructure keep up these increasing demands? Can you transform the wireless network infrastructure into a sensor to digitize your workspace without duplicating so much of infrastructure and added cost? Do you have a sustainable setup? In this episode, let's dive deep into how Cisco wireless solutions can help you to digitize your workspaces. Wireless technology has evolved significantly over the years, from 2 Mbps to multi-gigabit speeds. The introduction of Wi-Fi 6 in 2019 marked a substantial advancement, supporting speed up to 9.6 Gbps theoretically, a tremendous growth compared to 10 years ago when we had only 600 Mbps. Then in 2020, Wi-Fi 6E was introduced. But wait a second, Wi-Fi 6, Wi-Fi 6E, they sound somewhat similar. What's the difference between these two? Wi-Fi 6E is not a new standard, but an extension of the Wi-Fi 6 standard introduced to enhance overall performance with a faster speed, low latency, as well as more security. Theoretically, they offer the same speed, but the additional spectrum of Wi-Fi 6E offers more non-overlapping channel, potentially being able to deliver faster, more consistent speed than Wi-Fi 6. I mean faster and more consistent speeds than Wi-Fi 6. It can support high-density IT or IoT environments without any kind of performance degradations. And how does it achieve this? Wi-Fi 6E introduces a new 6 GHz band that supports more channels, 80 MHz and 160 MHz wide. When you're using this 6 GHz band, Wi-Fi 6E clients won't share spectrum with the Wi-Fi 4 or Wi-Fi 5 devices, so the connectivity won't be slowed down by older devices that is operating at a lower data rates. With now more non-overlapping channels, it resolves the challenges with the channel diversity as well as channel reuse in crowded places like stadiums, train stations, airports, and high-density office buildings. It becomes very valuable. Unlike the earlier Wi-Fi 6 versions, which operated only with the two bands, 2.4 gigs, as well as the 5 gigahertz band, Wi-Fi 6E now operates with the three bands, so including that 6 gigahertz band that I just talked about. Ultimately, users can send and receive data at highest possible speed in these wired channels more consistently. This makes Wi-Fi 6E the best fit solution for any kind of a high-density deployments, including modern workspaces implementing many IoT use cases nowadays, and also high-bandwidth applications, critical voice video collaborations, augmented reality, virtual reality scenarios, and even real-time immersive gaming scenarios. So when it comes to your Wi-Fi network, Wi-Fi 6E now represents, also called as the today's network, today's Wi-Fi, represents a significant leap forward in terms of the capacity, reliability, security, as well as sustainability. With Wi-Fi 6E, you don't have to really wait for the data. It's more like you're getting a VIP pass or fast pass to access the information. Whether it is for your today's hybrid workplace or modern workplace requirements or tomorrow's widespread connectivity, Wi-Fi 6E, Wi-Fi 6 are on the way forward. If you're still using the older version of Wi-Fi 6, Wi-Fi technology, migrating into Wi-Fi 6 or Wi-Fi 6 is really a critical step for your infrastructure to keep up with this ever-increasing demand that users, devices, things placing on your wireless network. So with the powerful customizable solutions for companies of all sizes, the Cisco wireless portfolio helped you to manage the growing number of connected wireless devices. I'm going to invite my colleague Ryan Casey to discuss this topic further.
Thanks, Ansar. Looking at where we are today in the wireless technology landscape, Catalyst Wireless provides full experience from end to end. As we look at the connected devices on our wireless infrastructure, such as laptops, OT platforms, wireless sensors, being able to provide all of that connection, all of that support on our wireless access points, as well as being able to take advantage of Bluetooth Low Energy devices connected directly to the wireless infrastructure. We then bring that back up into our access layer to where we're able to provide high bandwidth, high density, and multi-gig connections out to the wireless infrastructure, really creating that high density deployment and that high availability landscape that is demanding in today's wireless infrastructure. And this is all residing on our 9800 controllers, whether it be a cloud version, whether you have a hybrid cloud deployment, or whether you want to have an appliance, and being able to accommodate the various type of deployments that you would see in a landscape. So fully customizable and fully scalable for whichever deployment that you're looking to do in your office locations. If we take a deeper dive into the access points themselves, we see a shift from separating an on-prem approach versus a cloud-first approach to managing and deploying these networks to a more of a hybrid approach. We're looking at common hardware. So on our 9160 series, being able to manage that directly with a Meraki dashboard or Catalyst Center, really providing that flexibility to how your network is managed. We have IoT services native directly on all of these access points, which allows you to very easily turn on the BLE radios and provide gateway devices for BLE devices and sensors that you would deploy throughout each of your floor plates. Really creating a super highway to be able to leverage the infrastructure that you're installing to be able to provide additional functionalities and additional insights into each of your facilities. These sensors also have built-in environmental sensors, which adds another layer of visibility into the floor plate itself. So temperature, humidity, and VOCs, these can all be leveraged now directly from the access points, as well as being able to provide a very high density and high bandwidth infrastructure for your ever demanding needs on your wireless infrastructure. As more and more devices are brought onto it, laptops, sensors, this creates that common hardware, that common framework to be able to transport all of those solutions and all of those systems very uniformly back to whatever services that you would be implementing. When we look at management and network management as a whole, on the wireless side, we really look at two possible scenarios with a bridging between the two scenarios. So a fully on-prem solution and Catalyst Center, being able to host this in a physical appliance for high availability and disaster recovery, as well as a virtual appliance to be able to have in your data center or in your virtual machine infrastructure, whether it be hybrid or on-prem. And then as we transition over to a fully managed Meraki dashboard, being able to mix the two. So having through APIs, being able to share policies and share management, and as well as share telemetry that's from Catalyst Center into the Meraki dashboard. And then a fully cloud version of the Meraki dashboard, being able to manage all the infrastructure, all of your access points, and all of your distribution through that Meraki dashboard. And being able to natively manage and control Catalyst infrastructure directly in the Meraki dashboard. As we discussed earlier about the evolution of the wireless infrastructure, where we stand today, Wi-Fi 6 and Wi-Fi 6E, we're really able to solve the challenge statement, which is how do we provide better services in a post-COVID world where higher bandwidth is demanding for all the applications that reside on that wireless infrastructure. So with Wi-Fi 6 and Wi-Fi 6E, as well as mGig, we're able to improve that bottleneck and now have a common pathway to be able to really focus on those high bandwidth applications and the multiple devices that are now going to be connected through your infrastructure. Customers are having a Wi-Fi first approach, so being able to accommodate laptops, cell phones, wireless sensors, being able to accommodate the full myriad of devices and provide that seamless user experience and that seamless connectivity experience to those devices in this ever-demanding world.
Thank you, Ryan. By leveraging Cisco's robust wireless infrastructure, organizations can transform their workspaces into intelligent environments. Nowadays, modern offices are using new technologies like Internet of Things and wireless networks along with the Smart Workspaces platform to achieve different business goals. A prime example is Cisco Spaces platform, a cloud-based platform that utilizes existing network infrastructure as a sensor, helping organizations to transform their workspaces into a highly data-driven environment. Wireless network here serve as both a connectivity foundation and a sensor network, enabling seamless Wi-Fi coverage across the floor plate, and then data transmission from various IoT devices as well as sensors using low power wireless protocols such as like BLE, Zigbee, Thread. Then this data is sent to the Cisco Spaces platform for analysis, and it provides you with more actionable insights. It helps organizations to understand how their workspace is utilized, improve the efficiency, as well as like increase the overall productivity. And additionally, the Cisco wireless access points can also do even more by acting as the BLE gateways as well as sensors itself. This means they can help manage IoT devices without any additional gateways, BLE gateways, lowering the overall cost as well as boost the efficiency. By using Cisco's network infrastructure that you have already for communications, you are also setting the stage for more innovations in a modern workspace. Let us dive deep into these capabilities. Selected models of Cisco APs can act as the BLE gateways, facilitating connectivity or communications between BLE devices and the network. By serving as gateways, APs enable seamless integration of various BLE-enabled IoT devices such as like sensors, wearables, smart beacons into the network infrastructure. This integration enhances the visibility as well as the control of the BLE devices, enabling organizations to leverage the data that is coming from the sensors for various use cases, including asset tracking, environmental monitoring, and facility management. As depicted on the diagram, the data gathered from these BLE devices can be seamlessly integrated into Cisco Spaces platform for centralized management and further analysis. Once it is integrated, the data starts flowing instantly, and then the diverse ranges of apps within that Cisco Spaces platform presents this telemetry data in a graphical as well as easily readable format, offering users a comprehensive insight into the workspace dynamics and performance metrics. Cisco access points can also act as a beacon, like just as a sensor, emitting BLE signals to enable location-based services and proximity marketing. These beacons broadcast unique identifiers that mobile devices can detect, allowing for kind of a targeted messaging, indoor navigations, and asset tracking within the workspace. Depending on the Cisco access points model you have, you can set it up either as a base BLE gateway or advanced BLE gateway. The main difference is that the base BLE gateway uses native BLE app within the AP, also known as native mode, while the advanced gateway allows installation of IOX app on the AP as a container, also known as IOX mode. Both types can operate in transmit or scan mode, but the advanced BLE gateway offers extra features. Let's take a look at it, what those are. The advanced BLE gateways allows users to configure floor beacons and perform firmware upgrades directly from the Cisco Spaces dashboard. It can also receive telemetry data from the floor beacons. An AP can not only listen to the beacons, but actively connect to and configure and manage the third-party devices. So when you're choosing between the two modes, base BLE gateways or the advanced BLE gateways, consider your specific needs and choose accordingly. The base gateway is best for basic functions like broadcasting beacons or scanning for data, while the advanced gateway is more suitable for complex scenarios involving floor beacons management, advanced telemetry, and advanced gRPC communication commands. Let us explore a setup featuring a Cisco 9100 series AP designed to support IoT, functioning as a BLE gateway integrated with the Cisco Spaces. In this setup, the main components include lightweight access points equipped with the built-in radio, BLE radio, a wireless controller responsible for managing these access points, and a Spaces connector facilitating the connections between the wireless network and the Cisco Spaces platform. To enable IoT functionalities. You start by activating IoT streams on the connector, controller, and configuring the APs as a BLE gateways. This involves activating the BLE radios, enabling the BLE scanning, and as well as deploying the BLE gateway app through the Cisco Spaces dashboard. Once this is done, you can activate the IoT services, again through Cisco Spaces dashboard, and then proceed to onboard the BLE IoT devices. The Cisco access points then scans its nearby areas or surroundings around the particular locations for other BLE-enabled devices. And these devices could be BLE-enabled IoT sensors or beacons or other devices within the AP's range. Once the scanning is completed, the AP sends the scan data to the Cisco Spaces connector using the gRPC framework. That typically involves a bidirectional streaming service. This can be utilized to configure floor beacons and as well as receive the telemetry data from the floor beacons. The telemetry data typically includes information about the status, health, and the measurements from the beacons deployed throughout the workspaces. The Cisco Spaces connector dashboard receives that data transmitted by the AP. It decodes that data, extracting the relevant information such as like the device identifiers, sensor readings, location data. And once it is decoded, the Spaces dashboard displays this information in a user-friendly format, allowing users to visualize and analyze the data efficiently. All the BLE events as well as the telemetry can be also sent from Cisco Spaces to other partner applications as well as the customer applications via the IoT telemetry, IoT user action events, as well as the APIs. Select Catalyst access points feature 3 integrated environmental sensors: air quality, humidity, and the temperature sensors, enabling a real-time monitoring of the workspace conditions. The collected data seamlessly integrates with the Cisco Spaces platform, providing you with a unified view of entire connected environment. This integration allows you to track the air quality, humidity, as well as the temperature across different areas of your workspace, gaining insight into how the environmental factors impact employees' well-being as well as the productivity. You can identify areas with the poor air quality and uncomfortable temperatures, as well as adjust the space allocations accordingly. Additionally, these inbuilt sensors remove the need for you to run new cables or create an overlay of dedicated sensors, simplifying the overall installations as well as reducing the cost. Furthermore, they can integrate with existing HVAC systems as well as the other building management systems to provide critical inputs, enhancing the environmental control as well as facilitates the automations. Moreover, they can integrate with the other applications using the Firehouse API, extending their functionalities, providing more actionable insights to your various enterprise applications. Let us now delve into a setup featuring a Cisco 9166 access point equipped with an inbuilt environmental sensors and also its seamless integrations with the Cisco Spaces platform. In these configurations, the key components include lightweight Cisco access points with the integrated sensors and a wireless controller for the access points management, and as well as a Spaces connector linking the wireless network to Cisco Spaces platform. The Cisco 9166 AP securely transmits the sensor data to the wireless 9800 series controllers via CAPWAP tunnel, and the Spaces connector subscribes to the Yang model of the data receptions via the telemetry, securely forwarding it to the Cisco Spaces cloud through an HTTPS tunnel. The data is then displayed on the dashboards for further analysis in a user-readable format. While customers can access the raw telemetry information from the wireless controller side, the Cisco Spaces offers more comprehensive solutions with the real-time telemetry visualizations and also allows the compatibility with the other Spaces applications as well as the standardized event-based APIs for integrations with the third-party solutions as well. Let me now invite my colleague Ryan Casey to provide you with a demo how a Cisco access point can be configured as a BLE gateway using Cisco Spaces platform.
Now we'll do a quick demo on our IoT services for our access points, which allows BLE devices to be connected to our wireless access points and then begin to transmit any type of telemetry that they have associated with them. We're going to go ahead and log into our Cisco Spaces instance. And as we log in, we're going to go ahead and go to whichever particular tenant you're associated with. And then navigating to the setup wireless networks on the dashboard. And here's where we have multiple avenues. So you're able to connect your Meraki dashboard account via an API key, and then also your Catalyst wireless LAN controllers. Click on Add New. This will bring you to a prompt where you're able to connect the Catalyst or Meraki infrastructure and a quick step-by-step guide to be able to do that. Once your network is connected, we'll go ahead and navigate to the IoT services and IoT gateways. From here, we can go ahead and select the particular APs that you would like to deploy the IoT services to. And then from here, based on either wireless or wired connection, in this instance, it's wireless, and then being able to deploy that to whichever access points on the floor plate you need to have those services enabled. Once that is done, navigate to device management. And then here is where we can start bringing in those particular BLE devices that are on the floor plate and looking at each of those particular devices. So kind of a simplified deployment to be able to leverage that wireless infrastructure and add additional functionality on the floor plate.
Thank you, Ryan, for that great demo. Now, looking at Cisco wireless infrastructure through a sustainability lens, there are some big steps we are taking, as well as steps already taken, that help make our products more sustainable. From a hardware perspective, we are making our products with extremely efficient ASICs and optimizing the power usage of the different components in every product we make. We're also using more sustainable materials such as recycled plastics in the housings of our access points. Looking at our packaging, we are minimizing the use of plastic packaging materials and packing multiple products into the same box as much as possible to help reduce waste. Finally, when it comes to mounting your Cisco access point, you have a reusable mount that is the same design we have been using for over a decade. This saves you time on replacement and upgrades, but it also reduces the waste that would typically come from changing out devices. There are also a number of software features available from Cisco Wireless that help with sustainability, specifically on power usage. Cisco access points can be put in a power saving mode based on the profile for the device, as well as on a calendar for a same device. You're also able to allocate the power provided to the access point to specific radios that you would like to be on and turn off radios that are not in use on the device. Lastly, in Catalyst Center, you are able to see the power usage trends of a access point, allowing you to make changes if the device is not deployed in an energy efficient manner. Thank you all so much for joining our web series today. And if you missed previous episodes, please make sure to go to our YouTube channel by either going to youtube.com/@realestateredefined or by scanning the QR code in this web series. Next month, in episode 6, we will be covering the role of Catalyst Center. We look forward to seeing you then.